Right. Okay. Today we will complete the exercise ending topic, right? So we were discussing about typecasting. Now we are in a position to understand about the implicit casting. So which is also called as the widening, right? It is also called as automatic type conversion. So this is the widening order or the promotion. You can also call it as the promotion chart, right? So this one. This is called as the widening order or the promotion chart. So what is typecasting generally? So the one line answer is the process of converting from one data type into another, right? This is the one line answer. The process of converting the value, converting the value from one data type to another. Okay. So again, it is further divided into two types. One is what? The widening. So what is the widening? One line answer again. Widening is very simple. Converting smaller data type to larger data type, right? So what is narrowing? So that's the opposite of widening. What is narrowing? Converting from larger data type to the smaller data type. Larger data type to smaller data type. This is narrowing. Yesterday we have seen some examples on top of this now. Today we will look into few more examples. See, let us take now today let us talk about the char data type, right? When I say many of them did not do this here, only Shravani and Pranati did this. So when I ask you to solve a problem, try to do it because these are the questions. This kind of questions you would be expected. We can expect this kind of questions in an interview room. It may look simple, right? But we do make a lot of mistakes. A lot of mistakes will happen, right? Let me put this in the. Okay, at your free time you can do this. People who did not do this. Huh? Okay. So now what I'm saying is, let us take the char data type, and I'm saying like this. Okay, I am taking the variable, I mean a kind of letter A. Okay, within the single quotes, value A within the single quotes, which is getting assigned to the variable A, right? And what I'm doing, I just want to convert this. Okay, I just want to do the conversion. So first you have to think two things here. You need to think about two things. Okay, so here the variable name is A. So we got the variable name as A, right? So initially the A is what? A is of what data type? Character data type, char data type. Okay. Then in the very next line, I am doing what? I am assigning the value A to another variable B. I am assigning the variable A to another variable B, which is of integer data type, right? So you need to make two observations here. Initial state is character, then it is getting converted to integer. Second thing is, okay, think about the size. Okay, character can store data up to 2 bytes, right? Integer can store data up to 4 bytes, right? Initially A was given 2 bytes, now A is being given 4 bytes, right? So character is getting converted to integer. Variable A is of character type is getting converted to integer type, which means widening is happening here. Which means what? When you see initially it was character, now what happened? This character is getting converted to integer according to the promotion chart. Character is getting converted to integer. Look at the direction. It is from lower data type to higher data type. So we are discussing about the widening again. Right? So internally what would happen is, let us go back to the program. So when I do system.out.println, and I just use the print statement, right? So when I just access the variable A, now the output is very straightforward. You get to see what? Character letter A in the console or character A in the console. right? But when you try to access the variable b, at this time you cannot expect a character here. This time you will expect an integer. Why you are expecting an integer here? So this is what type of casting here? This is a kind of implicit typecasting, or we can call it as what? We can call it as the widening, means converting from lower data type to high data type. So automatically this will happen behind the scenes. This is what we have been discussing since yesterday, right? So internally Java will use the typecast operator and it will place the value integer, right? The unique code, okay, we have discussed this concept on our 5th class, I guess. Okay, so when you have a character, so behind the scene there will be a giant dictionary will be there, the Java library. Okay, this a would be pointing to the equivalent Unicode number. So Unicode number which is going to be pointing to again a integer number. Okay, a is internally representing a number which is nothing but 65. So b is representing 66, c is representing 67, like that, right? So this is the example. This is a good example where we can explicitly see that typecasting is happening behind the scenes. Automatic typecasting is happening behind the scenes. Able to follow? Yes, no? Or getting, you don't see much difference when we do the casting with the other data types, but when you tag character and the integer, okay, when you move the data type from character to integer, you get to see the difference. When you access variable a, you will see the character a. When you access variable b, you see a number, because this character is automatically converted to the integer by Java. Even if you use this or if you do not use this, no issues, the output is going to be a number itself. Able to follow? Yes, no? Hello?
Yes.
Right, now next see, now let us discuss about the this is the topic of discussion for the concept of widening. Now we will come to the next part, which is what? The narrowing. Okay? Narrowing. So look at this. It says explicit casting. Narrowing. So narrowing. The behavior of the narrowing is going to be a little bit weird, guys. Why? Because think it of like this. Okay. Let us imagine that you have a cup here. Okay. You have a cup. Okay? And you also have a big jar. Okay, so this big jar is full of water. Is full of water. Okay, so this is 100 ml cup. This is 1 liter jar, right? So when you try to pour down all the water from the jar to this tiny cup, right? So usually, as soon as the actual capacity is filled, okay, 100 ml is filled, the remaining would get overflowed, right? Overflown, right? The remaining would get overflown, right? Remaining water would get overflowed. So you don't get you cannot fit this 1 liter into this 100 ml cup, because the capacity itself, it says it is just 100 ml. It can hold up to 100 ml. You cannot fit the complete 1 liter of water to a cup which is of 100 ml. Here I'm talking about the sizes. Okay, firstly, when you talk about the size, this cup has the capacity of 100 ml. This jar has a capacity of 1 liter. Okay, when you talk about the water here, water is nothing but is equivalent to data, right? You can fill from the larger jar to a smaller cup up to a certain limit, right? After that, if you keep filling, everything will become what? Everything will be overflown. So here I am introducing one key. Here I am introducing one word which is called as what? The overflown. Everything will get overflown. Okay? So in Java, like if you apply this, okay, if you do the concept of, if you look at the concept of the narrowing means, this is what the narrowing is. If you look at the concept of narrowing, the overflown water is nothing but what? Loss of data. Example, very simple. I'm going to put it right. When you go by this direction, okay, if the direction is from left to right in the increasing order, okay, the another direction is from character and again this direction. When you move data from through this direction, okay, when you move the data through this direction, right? Okay. This is what I'm talking about. From by to short, okay, in the increasing order. Okay, in the increasing order. From by to short, short to int, long, float, double, or from character to int, then again this direction. If you follow these two directions, okay, it is called as what? It is representing the concept of widening. Okay, narrowing is nothing but if the directions are reversed, something like this. Okay, I mean converting from higher data type to lower data type. This one is reverse direction, right? And this one is also reverse direction. This one is also reverse direction. So the arrow marks in the red color, which is representing what? The reverse direction, which is representing the concept of narrowing, converting from higher data type to the lower data. And this is also reverse direction. Very simple example I'm taking. See, when I have something like, let us say, byte, or let me say integer a equal to 100, right? So in the very next line, I am saying byte b equal to a. Okay, remember two things here. Always remember two things. Okay, if I just do like this, compiler will not be very happy. It will throw an error. Okay, it says cannot convert from integer to byte. So there will be an error. Okay, compiler will not be very happy with this. Why? Because compiler is thinking like, hey, you are converting the value 100, which is of higher data type. Integer is what? Higher. Comparatively, comparing integer with byte, integer is of higher data type to the lower data type. So lower means what? Byte. Byte is representing lower data type. It's just like the this scenario, that we have just discussed, this analogy. So when you are trying to do this, right? Compiler wants us to do this explicitly. So we need to force the compiler that this is okay. How do you force a compiler? You will explicitly convert the integer. A is of integer type, no? Okay, you just typecast that to integer type explicitly. This job has to be done from your side. I mean, right? This job has to be done from your side. It is not automatic. Since you are a developer, when you want to convert a value which is of higher data type, higher to lower data type. Okay, the first line is higher. Okay, the second line is lower. Okay, compiler would expect you to add this typecast operator. Okay, this should be equal to this one. You are explicitly saying that okay, a has to be forcefully converted to byte before assigning it to the variable b, which is of byte type. When you don't do this, this is invalid. Compiler will give an error. Okay, the name itself says, okay, what is explicit casting means? Developer has to do this. Developer has to do this forcefully. To satisfy what? To satisfy the compiler. That's why it is called as explicit. Okay, what do you mean by implicit? Implicit means you, even if you do not do this, compiler will be like, don't worry man, I will do it for you. Explicit means we are forced to do this. Developer has to do this forcefully to satisfy the compiler. When you do not add byte here, we will be into trouble. If I just print this, okay, if I just print a and if I just print p, okay, you would get to see the same output, 100, 100, 100. This is the case one. So what is the case one? Case one is very simple. So I'm talking about what is the case one. So when you do the narrowing, so this concept is called as what? Narrowing. It is just like you have the byte data type and you have the larger data type, which is integer data type, right? And initially you have placed the value 100 in the integer data type, okay, and this is byte, right? So you want to do what? You just want to put this, okay, you just want to put the value, put the complete value, store this complete value inside the byte data type. You want to fit this value inside the byte data type. In order to do the fitting, okay, this concept is called as what? The narrowing. In order to do this, you need to convert this value 100. Okay, you need to convert this value 100, which is of integer type. It is of integer. It is saying I am integer type. If you want to hold me, first convert me to your type, okay, then assign it. Okay, here 100. Okay, by looking at this, I can say this 100 is of which type? This 100 is of integer type. Integer type. If you ever have to convert this data, convert this value which is of integer type to byte type, right? In order to make it fit here, this value needs to get converted to byte type first, then you can fit it inside. Okay, in order to do this, you need to use the typecast operator, which is what? You need to explicitly say that, okay, byte. When you do this in the code, okay, now it is okay to fit here. Now this value can be fit inside. Have you got what I'm trying to say? Hello? What is explicit typecasting? Are you getting this? What is narrowing? Hello? Yes, no? Open your mouth.
Yes, sir.
Others? Pranati, Pavitra, Ravani. Getting it?
Yes, sir.
Okay. Listen, listen. So there is a lot of there are a lot of things to discuss here. So this is fine. This is completely fine. Sometimes what would happen, sometimes we try to have a value something like one. Let us take 130. Tell me one thing. 130 is a value of integer type, right? I am trying to fit 130. I'm trying to convert the variable a, which is holding the value 130, to the byte type. What is the maximum range of byte? Minimum range is minus 128
128.
to positive 127, right? Hello? Yes or no? So we are trying to do what?
Yes, sir.
We are forcefully trying to convert the value 130, which is of integer type, the byte type. But the problem here, there is a big problem here. The range of byte is from minus 128 to positive 127. What would happen in this situation? Will the compiler will throw an error, or will there be any runtime error? Is it allowed? Is it not allowed? Okay, if it is allowed, what would be the output? Okay, let me run this. What you are saying? You are seeing what? Negative minus 126. Minus 126. A kind of garbage value, I can say. A kind of data loss, I can say. A kind of data. We will look into why we are getting this number. So what is happening internally is focus here. Okay, so this is so what is happening in again. Okay, let us say there are two jars. Okay, my byte, this is the byte jar. Okay, it can hold value maximum positive value up to 128. Okay, but the integer jar, okay, the integer data type, okay, you have stored the value 130. Okay, and you wanted to do the typecasting, you are doing the narrowing, means converting from larger to smaller. This is called narrowing. Okay, but my byte, the storage level for my byte is up to positive 128, right? But when you try to do this, okay, you cannot do this automatically. You need to do the cast operator. Okay, to do what, you need to use the typecast operator. This is what byte, you need to do this conversion, right? Internally what would happen, it consumes some value, right, from between the range minus 128 to, my screen is visible now.
Yes, sir.
Yes, sir.
Okay, so it consumes value from minus 128 to, this is the range of a byte, right? Positive 128, right? So the cycle will be like this, guys. Okay, cycle will be like, also up to 128, it can hold up to 128. Okay, after this, so there are, two more values, it will be cycling around like this. So 128. Okay, after this, so the actual value is 130, no? So we are two numbers less, right? So again it will cycle back here. Okay, minus 128. Again it will cycle back here. Minus 127. Okay. After this, minus 126. It keeps cycling from the maximum point. Maximum point is what? 128, right? So we are running out of two shots, right? So again it will cycling back. So minus one. This is going to be minus one. This is going to be 129, 130. Okay, and the latest value is 126. I will help you with the formula. The point that I want to discuss about is what? There is a huge amount of data loss. So when you do narrowing, you should expect what? You should expect the data loss. Data can't be protected. When you do narrowing, what will happen? Precision will be lost. Data will be lost. So if the data is lost, what's the point of doing this narrowing? Okay, I will give you the real-time example. Real-time example would be like this. Okay, see, when you have, so there are two types of mobile devices. Okay, let me say you have the Android device of the latest version. Okay, and you have the what we call as Nokia older version. Okay, which is not even an Android. Simply a color phone. Nokia color phone. Okay, which is of 2004 model. Okay, this is of 2026 model, right? And so this has the active SIM card. This has also active SIM card. This both mobile supports pictures. The both mobile supports pictures. Pics. So you can do the transfer. You can do the data transfer. If you want to transfer pics between these two mobiles, you can let us say that you can transfer pics. You can send picture messages. For example, in the Android phone, okay, if you want to send a picture message, let's say this is a picture of a mountain with high clarity. Okay, since the Android phone, when you say Android phone, it is going to have at least some crucial memory. Okay, some amount of memory. And the resolution will be very much high because the phones are improved, right? Phones are improved, quality has been improved. The pixel level is going to be very high. But still, if one of your friend is using a older phone of 2004 version, you want to send a picture message, right? So what happens? Okay, this data, okay, the pixel amount will be reduced so that it gets compatible to the Nokia version. Means it here it could be around 1098 pixel, but after once it is from the receiver side, the pixel quantity will be reduced because the memory support is very less here. The memory storage support is very less here. according to the memory storage, okay, the size of the picture will be reduced. Okay, here he would be receiving like in KBs, 15 KB, but from the sender side it would be like 5 MB. Okay, here the operating system, the Nokia phone should reduce the pixel force, reduce the size of the picture forcefully so that it gets compactable in the receiver side in the Nokia cell phone. This is one of the analogy, right? So likewise, there are some areas, okay, when you do not worry about the data loss. So when the data loss is not a topic of discussion, okay, when you are okay with the data loss, okay, you would go for what? You would go for the concept of the narrowing. So to make that to make the older system and the newer system, okay, to make the older system and the newer system compatible, to make the older system and the newer system to communicate by ensuring the compatibility. Making sense? Hello? Little bit idea you got why narrowing is required? Yes, no?
Yes, sir.
We will look into another example. Forget about this. Let us say that I have purchased a petrol. Okay, let me say today you purchased a petrol and the price tag says, okay, it is like something around 110 rupees 98 paise. There is a big board outside the petrol bank and the rate has been displayed. Today's rate is 110.98, right? So let us say that, okay, in our home we are tracking expenses every day. Now we are tracking expenses every day. If we do not worry about the precision, okay, if we do not care about the fractional part, okay, we do not care about the fractional values, we can go for typecasting. You can go for what? You can go for the concept of narrowing. I can use the integer, okay, so extract integer. Okay, I'm taking the variable as extract integer, okay, I'm taking the variable petrol here, okay, so I'm just typecasting it here. Means now you should think, okay, what kind of typecasting is this? Implicit or explicit? This is explicit. Why? Because float is the larger data type. Okay, I am just converting the float data type, okay, from the float to integer. I am coming in the backward direction, in the direction of the red line, coming in the backward direction means narrowing. I am talking about narrowing. Float is getting converted to integer. So I am talking about the concept of what? Narrowing. Backward direction. No? So explicit typecasting is mandatory. Okay, I should typecast. I should use what? Since here it is integer, here should also be integer. Right? If I just print the extract integer, okay, I will be losing the fractional values. I will be losing the decimal values. I am okay with that. I'm very much okay with that. You would get to see 110 only. I'm very much okay with. I'm very much happy with that. Okay, sometimes the fractional part would be like this. Okay, forget about petrol price. Let me for the stock market price and all. Okay, let us say that you have profited something around 10,000 today. You really don't care about what? You really don't care about the fractional part, right? So that is okay. So we are able to extract only the integer part. When we don't care about the precision here, it's completely fine because the value is what it is completely negligible in nature. Yes or no? Understood the one more use case here. Hello, hello.
Yes, sir.
Others. Type yes in the chat box, everyone. Type yes, yes, yes. Let's see. Are you active or not? Okay. See. Now you might be thinking, sir, how did we end up in getting a random value? So you do not want to worry about this, but In order to feed your curiosity, I'm going to tell you, write b equal to, sorry, let me say integer, let me say integer a equal to 130, write b equal to a. So I'm doing the narrowing. The question is, how do we end up getting the value 130? To understand this, I will help you with the formula. What is the range of the byte? Okay. So what is the range of the byte? Anyone know what is the range? When I talk about the range, you should include the minimum and the maximum value. So this is the formula to calculate the range.
-1.
Yeah, correct. Minus 128 to positive 127, right? But total, how many numbers it can accommodate? Okay, if you want to calculate the exact numbers it can accommodate, okay, just do this calculation. Okay, something like maximum is what? Maximum is 127, no? Minus, right? So minimum is what? Minus 128 plus 1, right? So further evaluation, you would end up in getting what? Minus 127, okay, minus again, minus 127. Okay, so after the further evaluation, 127 plus 127. What is the range? 256. So I'm talking about the the actual numbers that can accommodate. Okay, this includes minus 127, minus 128, 126, every number then counting. If you count each and every number, totally 256. Do you agree with this? Hello? Yes, no? Hello? Are you getting this? It's like this, guys. Okay, don't get any confusion here. When I start counting from minus 128, okay, from minus 127, okay, and till, okay, you have 0 until, okay, plus 126, okay, plus 127. If you count each and every number, you would end up in counting 256. Now you understood?
Yes, sir.
Are you getting this? Right? So what is the second thing? Okay, so you have to take the actual value. Actual value is what? 130, no? Do the modulus of 130. Modulus of, take the actual value, which is integer, 130, do the modulus with the range, 256. Right? So when you do the modulus operator, when you perform the modulus operator, you get 130 only. You get the resultant value as what? 130 only. Right? So after this, do 130 result value minus 256. Can someone tell me what is the answer for this?
-126.
That is what we got, or we are getting some other answer here. So 130. 1 minute, guys. My formula is wrong. So result value 132 physics. So 130 minus 256. The range is 136. Here I will substitute the value 130 here. So this is the actual number, modulus 256. So you get what? When you do this, you get 130 only, right? So when the number is greater than 147, you have to do 130 minus 256. Okay, I should calculate for p. So I should print the value b. Okay, I was printing the value. Okay, minus 1. Let me come again. Okay. So we got to know how to find the range. We got 256, right? Okay. Now what I am doing, the actual value. This is the value. This is the integer value. Do modulus operator with the integer value, and this is the range of the lower data type. Range of what? Range of the lower data type. If we perform this calculation, okay, since the denominator is larger than numerator, it will always be the numerator only. First, it will calculate the remainder. Since the denominator is larger than the numerator, the output is always a numerator only. So what the formula says, if the result, okay, this is the result. If the result is 130 is greater than 127, okay, do result minus what? 256, which is what? 130 minus 256. You will end up in what? You will end up in getting the number minus 126. Are you getting this? Okay, let us do this for another one. Instead of 130, let us do this for 135. Okay, you will end up getting some other number here. Minus 127. Why minus 127? Right? Use the same formula. Okay. So here the number is going to be what? 135. Value is 135. You do the modulus operator, 135 modulus 256. Okay, since the numerator is smaller than denominator, okay, the answer is always the numerator only in the modulus operator by using the modulus operator 135, right? So again this 135 is greater than 127. Okay, and do this 135 minus 256. So you will end up in getting the number which is displayed here, minus 126. Okay, so see, let me tell you something. You do not have to do all this calculation. Are just the overflown value. Okay, I am just giving you to understand what is happening behind the scenes. This is not at all required. You don't need to calculate all these things and find the answer. No one is asking you about this. One thing they will ask you is what kind of typecasting is this? Sometimes the question would be like, okay, if I run this code, will it execute or not? Now someone tell me, if I run this code, is it valid code or invalid code? Can someone tell me? I keep the code like this. Is it going to be a valid one or an invalid one? Invalid. Why? Because you need to think logically. So a is of integer type, right? We are trying to convert integer to byte, okay, which means what? Higher data type to lower data type, which is a concept of narrowing. Narrowing means what? You should explicitly add this cast operator. This is how the question should be. The another example I said, no, when you do not care about the precision, okay, let us say double the value of double d equal to, let me say something like, so I am representing the data with, there are so many fractional part. Okay, in the very next line I am taking float e equal to d. I am converting the higher data type to the lower data type. So definitely the left hand side data type should be typecasted to the compact, to make the right hand side data type compactable. Right? When I try to print the value of e, see here, the data is with high precision. Okay, there are a lot of decimal values. After the conversion, you lose some data. Okay, if you do not care about the precision, okay, if you care about the integral part, or if you care about a certain limit of precision, it is okay. That is completely fine. This knowledge is more than enough. This knowledge is more than enough. See, sometimes see, integer a equal to, let me say 75. Okay. Character b equal to, first tell me, is this valid or invalid? Think and tell me, is this valid or invalid?
Invalid.
Why invalid? Yes, it's invalid only. Why invalid? Because why it is
Character ranges
2 bytes, correct. Integer ranges, I mean, integer size is 4 byte, character size is 2 byte. So what I am doing here, okay, I am trying to convert from higher data type to lower data type. So I should typecast this explicitly. I should do this. Now focus here, what is exactly happening? If I, after doing this, you have a number here. I have a number here. I am trying to typecast this variable to a character. Okay, definitely this character will extract the actual character from this particular number. So just try to print B. Okay, now the number is typecasted to the actual character that is mapped to that particular number. Are you getting this? Hello? Yes, no?
Yes, sir.
If I do 85, okay, you want to find the what is the actual character that is mapped to the numerical value 85 in the Java library. You can do this way. You let me take any other number. Okay, what is the actual character? Some other language. Let me take any other number. See, I don't know whether Hindi or Sanskrit, I'm not sure. Let's say some other number. You're converting the actual number to the equivalent character. So how we are able to achieve this? The concept of typecasting, which is concept of what? Narrowing. Right? So this narrowing is also helpful in to perform that. So now tell me one thing, guys. Okay, I have byte a equal to 10, byte b equal to 20. So tell me, is this valid or invalid? Let me see who is going to tell this. Valid or invalid? Remember one thing.
valid.
No, it's invalid. Why? Because I have told this already. Whenever you are performing an arithmetic operation between two variables of byte type, okay, arithmetic plus on two byte type, the output will always be what? This will always, the evaluation will always expect an integer value. You remember or not? Previously we have discussed this. I think Pranati should aware of this, Ravani should aware of this. In the class number 4 or 5, I guess, I'm not sure. So when you try to do the arithmetic operation on the byte or short data type, the resultant value is always going to be what? Integer. I have given you the table, if you remember or not. I said no, byte plus byte, okay, will return you what? Integer. Short plus short will return you what? Integer. Okay, and short plus byte will return you what? Integer. And byte plus short will return you what? Integer. Do you remember this table? We have discussed already. Hello? Yes, no?
Yeah.
Remember, no? So same thing, okay? Since it is expecting an integer, okay, it is getting evaluated to an integer, no? Okay, so the resultant value is an integer. Typecast it to the compactable data type. So what you can do here? Okay, you can just put this in one bracket and you can typecast the. Now it is solved. It is possible only because of narrowing. So on arithmetic operation also, they would simply give you this kind of question. Okay, what they will say in the notepad. Okay, so they just say They just put this in the notepad like this. They will ask you, tell me what would be the answer. So we are very clever, no? What we would say, what we would end up in saying, okay? Not about the clever. We think we don't think logically, okay? We say 10 plus 20 is 10 plus 20, 30. So we end up in saying 30. We don't even have a kind of bothering that. Why would they ask even this kind of simple question? You won't even think about that. So this is invalid. Why this invalid? You should say, okay, this becomes valid only if you narrow it down. If you perform the explicit typecasting, you should convert it to byte type, because arithmetic operators on two byte data type will end up in giving what? Giving the integer. Are you getting this? This is also one of the interview questions. Hello?
Yeah.
Getting this, no? So byte. Okay, one more question. Let me say, if I say short, byte plus short, okay, A is of byte type, B is of short type. Always remember, okay, this will return an integer. It's going to return an integer. Okay? This integer and this byte is not compactable. So that's why I'm converting it to make it compactable. Okay? Any other combination, short plus short will not return a short. Short plus short will return an integer. I should make that to the compactable. Okay? So why here it is not giving error? You can either, the resultant value, you can either use short here. Okay, both sides should be same. Even you can use the much lower data type also, no problem. You are converting it explicitly. Okay, I want, you are saying it clearly to the Java that, hey, on my right hand side it is getting evaluated to short. Okay, I am keeping the short data type in the left hand side so that both gets compactable. Okay, how to avoid this error? Okay, without typecasting, I simply put integer, no issues. I simply put integer, no issues. Okay, instead of integer, if I am using the lower data type, this addition operator will expect an integer value. So you should convert that integer to what? To the equivalent data type, which is short. Whether it can be same and this can be lower than this data type. That is also fine. Both are okay. Short, you can use short, or it can be lower than this data type. It cannot be higher than this data type. Are you getting? Hello? In the practice, you'll get a lot of confidence. Okay, by just by look, no, just with my teaching, it will be very difficult to understand the first go. With the practice, you can get this better. So by this, I can conclude that the topic of typecasting is over. So what is typecasting? So you have something like implicit typecasting, explicit. Implicit means Java does automatically. Explicit means programmer has to do manually, right? Implicit means what? It's converting smaller data type into larger data type. So you will not have any data loss. Data loss will not be there. Data is completely guaranteed, right? But explicit data type is what? It's a kind of what? You have to do it forcefully. You have to do it manually, right? So importance of deriving arithmetic operations, right? So when you try to add 2 byte, the resultant value should always be the integer. So you act accordingly. Okay, you cannot have a data type byte for the resultant. This is going to give an error. I will give you everything in the notes. Don't worry. The formula, you do not have to remember this formula. Nothing. Okay, this is for our understanding. I have given you why we are losing some value. For that explanation, I am giving it to you. Okay, shall we proceed with the next topic, methods? Hello. Hello. Are we good till here?
Yes.
Do you require any clarification? So with this, we have completed the Java variables concept. Okay. Now we will discuss about methods. Then after methods, we'll discuss about the conditional statements we have the loops we have. Okay, we have to cover those two, then we can start discussing about OOPS concepts. Okay. I will give you the simple idea about what is a method. Okay. What is a method in Java? When anyone is asking you what is a method in Java, what it says, a method is what? A method is a block of code that performs a task. It's just a block of code that performs a specific task, right? So it can be called from other parts of the program. Okay, the two keywords, I mean, the 2 points that you have to remember when it comes to method. The main important point is reusability. Remember this word, reusability, and the code organization. Okay, so for example, so this is our class. So far we know only one method, which is what? The main method. We know only one method, which is of main method, and we know another keyword which is called class. You know what is a class and you know what is a method. So why main method? Main method is a method where the execution starts. It is an entry point. This method is already there in the Java library. Okay? And this is also called as a method. But it is specifically you can call it as what? Main method. It is already there in Java library. It acts as an what? Entry point. Entry point and the exit point. Okay, all the instructions inside the main method will get executed. Okay. So this is given by the Java people. What if I want to create my own method? What if I want to create my own method? What if I want to write my own logic? Okay, what if I want to call the method? What if I want to call my own method? So why I want to create my own method? Because I want to reuse the code again and again. I want to reuse the code again and again. I want to keep my code organized. Okay, you cannot write everything. You cannot write everything in one main method. So when you have a lot of a business logic to be focused, okay, it won't be ideal to keep everything in the main method. You need to separate the functionalities. You need to separate the logic. You need to separate the behavior. Okay. So one method, okay, you can separate the methods, like one method you can do the calculation. Okay, other method can talk to database. Okay, other method can do some other thing. I want to separate the behavior, right? Okay, sir, how do I create my own method? How do I create my own method? So to create our own method, okay, Java says to follow the basic syntax. The basic syntax. You have to follow the syntax. Sir, what is the syntax? So this is the block. This is a method block. Access modifier. What is an access modifier? So access modifier, you can use 4 different kinds of keywords. Okay. So you can use what? You can use public here. Okay, you can use private, or you can use protected. If when you do not use anything, it will be treated as default. When you don't use anything, it would be treated as what? The default. By pronunciation, it is default. You will understand what is public, what is private, what is protected, what is default. Okay. Any one of these keywords can be used in place of access modifier. You will understand these things in detail, okay, as we go. We will connect all the dots. Okay, what is an access modifier? Access modifier are nothing but so there are 4 types of access modifier. First of all, we'll understand how many types: public, private, protected, and default. Okay, what is public, what is private, what is protected, what is default? We will understand that in detail as we go. And second thing, okay, look at this return type. Something like return type. Okay, this return type can be anything. You can use any one of the 8 primitive data types. So what are the 8 primitive data types? You know, no? You can use byte, you can use short, you can use long, any one of the 8 primitive data types. Or you can use class types. Class types means nothing but, okay, there is something called string, string buffer. Okay, so these are the future topics. So if you do not like to use these things, you can simply put void. Okay, you can use, for now let us stick to this. Okay, you can use any one of the eight primitive data types, or you can use void. Forget about this, not required. The future class will discuss this. What is string, what is required. So what is the method name? So you can define, you can give your own method name. The method name can be what? Any meaningful name. If you are calculating, you're developing the calculator application, okay, or if you want to do the addition, okay, you can use the method name addition or adding two numbers. Okay. Any meaningful name you can give. It's up to you. But it should follow what? It should follow the camel case naming convention. So we know what is camel case naming convention by now, right? So it should not start with a number. Okay, you cannot use the special characters except for dollar and underscore, right? You cannot have a space. You cannot start with a number, right? And the first letter should be what? The first letter of the first word should be in the lower case. Okay, first letter of the first word should be in the lower case. Okay, and the first letter of the consecutive word should be in uppercase. This is what the camel case. And the parameters. We can pass any parameters. For now, let me keep it as an optional. You can pass any number of the parameters. I'll tell you what is this parameters. Method body, you can write your own logic. Okay, if I want to build a simple method, how I can build is, okay, I am creating my own method. Okay, access modifier. In place of access modifier, I am taking public. Okay, in place of return type, what I said, you can use any one of the 8 primitive data types, or you can keep void. Method name. Method name is what? Let me take any name. Okay, my method. I'm practicing camel case naming convention. Parameters, I'm keeping it as an option. Method body. Okay, so inside the method body, I'm keeping my own instruction, system dot out dot println, okay, my method. Okay, this is how we can build a new method. So it should have what? It should have these things. Okay, this is the access modifier. Okay, this is the return type. We will understand what is void in detail. Okay, so we are just talking about how to build a method. So this is the method name. Okay, so if you want to discuss this part by part, we will have the discussion. Okay, there are parameters. This is called as what? The parameters. I'm keeping it empty for now. This is the method body. Okay, these are the instructions. Only one instructions I have done. Thank you for rejoining. Okay, I just want to complete this. Okay. So this is a simple method. Okay, and again you can differentiate methods in two ways. Okay. If you use static keyword next to the access modifier, it is called a static method. If you do not use static keyword, it is called as non-static method. Okay, let me build this method for the static keyword. Let me remove all this. Now inside the class, I'm taking, what is the first thing? Access modifier. I'm taking it as public. What is the second thing? Okay, I want to take it as a static method. I'm using the static keyword. Okay, what is the third thing? Third thing is what? I'm keeping it as void. So what is the fourth thing? Fourth thing is what? The method name. Okay, let me say hello world. Okay, and parameters I'm keeping it as empty, and method body. Inside this I'm just using what? System dot simple. I'm just I want to print something in the console. I'm using the print statement. So this is the predefined method. This method is given by the Java people. This is the user defined method. Okay, the question is I can have any number of instructions inside my main method, okay, or predefined method. Let me say I can have the first instruction, right? Let me say main method. I can have any number of instructions. Okay, let me say one. Let me say two. Let me say three. Right? If we run this code, ideally we would end up in seeing what? Only these instructions are getting executed. Because I was telling you for a long time now, all the instructions inside the main method will get executed. But what if I want to execute this method? What is the procedure to call this method? What is the procedure to call this method so that I can have this instruction executed? How do I do that? Okay. First check, okay, what kind of method is this? So this is what? This is a static method. This is a static method. Since it is static method, just use this method name, okay, and end with semicolon. Right? If I want to see the execution, okay, so we know these things already, right? So this is going to get saved as a.java, right? And behind the scene there is a compiler. The compiler will check for errors. If there are no errors, it is going to generate the dot class file. So a.java becomes a.class. Next, the JVM gets activated. So what is the job of the JVM? The JVM will consume this a.class file, okay, and it creates a main thread. The main thread is going to execute all the instructions inside the main method, right? So it will try to execute only the main method instructions inside the main method. Okay, what is the first instruction? First instruction is what? Main method. It will get displayed in the console. Second is what? 1. Third is what? 2. Okay? And the fourth one is what? 3. After this, it is going to encounter a method call. So this is called as what? This is called as the method call. Hello world. Okay, within the class, it will try to find is there any method by the name of hello world. It will just check all instances in the class. Okay, it has found the method by the name of hello world. Okay. Now from here, from the main method, the control is being transferred so that the instructions inside this user defined method now will get executed one by one till the end of this block. Okay, now hello world will be an entry point because control is getting transferred from here to here. This is called as what? Method call. Okay, hello world is what? Hello world. Okay, you are using the method name, which means now the main thread will know that okay, there is a method by the name of hello world. It will search for that. It's going to do what? It is going to search for that, and all the instructions inside the hello world method will get executed. For now, we have what? We have only one instruction, which is what? The hello world. Hello world will be displayed. Okay, and after completing the execution of the user defined method, okay, it comes back to the same place and it will check for is there any other instructions in the next line. Since there are no instructions, okay, it goes back to the JVM and this will be destroyed, and you would see what you're supposed to see in the console. Okay, if I run this code, hello. Okay, now see, let me remove all this. Okay. Now I can call this hello world any number of times. Every time the control will be transmitted to the hello world method, instructions gets executed and it comes back and again transmitted to hello world and again comes back and again. So see, I am able to reuse the same method over and over again. I'm not writing the hello world for 5 times, but I'm calling that method for 5 times. This concept is called as what? Reusability, which can be achieved with the help of methods. You can have any number of instructions. For our understanding, I am using only one statement inside this method block. Are you able to follow? Yes, no? Hello? Getting it? See, you will understand more about the Java methods. This is just the introduction. We have to understand what is this public, why we have to use public, what is the point of using static, what if I do not use static, what would happen, okay, what is this void, what is the purpose of this void, okay, and what is this why the parameters are left empty here, what can I add here, which we will complete tomorrow.